Good morning, everyone, and welcome. My name is Rishab Sunil, and I will be presenting the Green Practitioner module on circular operations, production, and logistics. I will be joined by our moderator, Alessandra Hinojosa. I'm also delighted to welcome Dr. Ramesh Subramoniam, who is the Director of Undergraduate Programs and Research at UT Dallas, along with Mr. Ajay Vonkarey, who is a Sustainability Advisor at Cognizant. They both have extensive knowledge of the circular economy, including food waste and reverse supply chain. A widely cited guiding philosophy for circular operations comes from industrial ecology and supply chain management. Design out waste, keep products and materials in use, and regenerate natural systems. Every product around us, this laptop, your coffee cup, and the chairs you're sitting on, was extracted, manufactured, shipped, and will eventually be disposed of. How we manage that journey is one of the biggest levers we have for sustainability. Over the next half hour, we will learn the difference between linear and circular modules. Look at why the current model is failing and why the circular alternative looks like, and how the real companies are making it work profitably. Let's get started. Here is our roadmap for the session. By the end, you will be able to do 5 things. First, explain what circular operations are and how they differ from linear production. Second, describe how circular productions cuts waste, emissions, and resource depletion. Third, and this is the toolkit, understand EPR, extended producer responsibility, life cycle assessment, remanufacturing, packaging strategy, and the regulations that support circular systems. Fourth, we will ground all of it into 2 case studies, IKEA and Schneider Electric. And fifth, we will finish on honesty, why credible sustainability claims matter and how to avoid greenwashing. We will then move into the expert Q&A. So let's start with the problem. The dominant model of production is linear. Take, make, waste. We extract resources, manufacture products, use them, and throw them away. You can see the chain on the right. Extract, make, use, and dispose. 2 numbers tell us the full story. Global material use has more than tripled since 1970, and it is still rising. Yet only 7.2% of the materials we use globally are cycled back into the economy, and everything else leaks out as waste. This drives climate change, biodiversity loss, water stress, and toxic pollution. But notice the business angle too. A linear model is economically fragile. When supply chains break, and we've all seen that happen in the recent years, dependence on virgin materials becomes a real vulnerability. A good example is a situation with tariffs in the US and the increase in commodity prices. So, what is the alternative? The Ellen MacArthur Foundation defines it well. A circular economy is a system where materials never become waste and nature is regenerated. The key word in the slide's title is design. Circularity is built in the start, not bolted on at the end. 3 principles drive it. 1. Eliminate waste and pollution. Design out negative impacts from the very beginning of the product lifecycle, which decouples economic growth from the consumption of finite resources. 2. Circulate products and materials. Keep items in use at their highest value for as long as possible through maintenance, reuse, refurbishment, remanufacturing, recycling, and composting, all underpinned by a transition to renewable energy and sustainable materials. 3. Regenerate nature. Go beyond doing less harm and actively enhance natural systems. Circular strategies can cut global greenhouse gas emissions by up to 39%, recover value from the 8% of pre-customer stock wasted annually, which is valued at over $163 billion, and even lower the virgin material usage. So what does this look like operationally? There are 5 building blocks for this. Design for durability, which are when products built to last, be repaired, and be upgraded rather than be replaced. Repair and reuse systems, in-house or third-party services that extend product life. And note, these create new revenue streams, not just extra costs. Reducing material waste, which is lean manufacturing, precision processes, and byproduct recovery to minimize input waste. Reverse logistics, the systems that bring products and packaging back from customers for reuse, repair, or recycling. And closed loop supply chains, which are materials recovered at the end of life feed straight back into the same production process. The goal statement at the bottom ties it together, redesigning how business works, across design, manufacturing, logistics, and customer service to eventually decouple growth from resource consumption. Now, the policy tool that makes producers pay attention is the extended producer responsibility, which extends a producer's responsibility for a product into the post-consumer stage of its life cycle. In plain terms, if you make it, you are responsible for it after the customer is done with it. There are three mechanics that matter here. First, the producers fund and organize collection, sorting, and recycling, shifting those costs away from municipalities and taxpayers. And most importantly, EPR changes design behavior. Modulated fees reward producers who design for recyclability and penalize hard to recycle materials. You will most often see EPR applied to packaging, electronics, batteries, tires, textiles, and vehicles. If EPR is a stick, life cycle assessment is the measuring tape. LCA is a method for systematically evaluating a product's environmental impacts across its entire life, from the cradle to the grave. The 5 stages run along the bottom of the slide: raw material extraction, manufacturing, transportation, the use phase, and end of life. So why does this matter? It replaces guesswork with evidence. LCA pinpoints hotspots, the specific stages that contribute most to carbon emissions, water use, or toxicity. And sometimes the answer is surprising. The biggest impact may sit in the use phase, not the factory. But those results feed directly into eco-design choices, supplier selection, and corporate sustainability reporting. A product carbon footprint is extracted from an LCA by isolating the total greenhouse gas emissions generated through a product's life cycle. It is expressed in units like kilograms of CO2's equivalent per unit of product, acting like a nutrition label for a product's climate impact. Based on the ISO 14067 standard, it allows comparison of carbon footprints across different products, identifying key emission hotspots for targeted reproduction. The short version, you cannot manage what you have measured. Here is a distinction that trips people up. Recycling and remanufacturing are not the same thing, and they are not equally valuable. So walk down this comparison table with me. Recycling breaks a product down into its raw materials. You keep the material value, but you lose the components, the design, and the labor that went into it. And it takes significant energy to remelt and reprocess. Remanufacturing itself restores the product to its like-new condition, and you retain the full product value, and it typically uses far less energy because you are repairing and restoring rather than starting over. The headline sat on the right. Remanufacturing saves about 85% of energy compared to with producing a new product. It is already common in automotive parts, electronics, industrial machinery, and medical devices and furniture. The principle to remember: recycling remains essential, but in circular systems, it should be the last resort, not the first response. And circularity doesn't only happen inside one company. It also happens between companies, where industrial symbiosis occurs when firms in a network exchange waste, byproducts, energy, water, or materials, so that one company's output becomes another company's input. The classic example is Kalundborg in Denmark, the world's most cited case. A power station and oil refinery, a pharmaceutical company, and others exchange steam, fly ash, sulfur, and treated wastewater in a closed network. And it has operated successfully for decades. Eco-industrial parks take the idea further. Planned zones where companies deliberately co-locate specifically to share resources. And even the benefits stack up. There are lower raw material costs, lower disposable costs, and lower environmental impacts. And they all happen at the same time. Plus, a supply chain that is more resilient because key inputs come from next door. Packaging is where most organizations meet circularity first. The headline on the slide is the big idea: system design over material substitution. A refillable system is far more effective than simply switching from one single-use material to another. 5 approaches, roughly in order of ambition: refillable and reusable. Return and refill systems like glass bottles and refill pouches eliminate single-use waste entirely. Recyclable materials favor mono materials or clearly labeled combinations that actually fit existing recycling streams. Minimalist design, which shows reduced packaging weight and volume without compromising product protection. Responsible sourcing is where certified materials such as FSC paper and verified recycled content reduce upstream impact. And biodegradable or compostable materials, generally useful for food contact or organic waste streams, but only where composting infrastructure actually exists. The caveat matters more than people think. So let's see this in a company that everybody knows. IKEA's Circular Product Design Guide is revised in 2024 and it sets several design principles that apply to all new products. Among the key ones, design for renewable and recycled materials, design for repair, design for disassembly and reassembly, and design for recyclability. There are two concrete examples of this. The Billy bookcase, one of the most produced pieces of furniture in the world, was redesigned with snap fittings replacing nails and paper foil edge bands replacing plastic. The result is that easier disassembly, easier repair, and easier recycling. Next is the Groinster chair seat, which has a shell that contains a minimum of 60% recycled content, and it was deliberately designed without glass fiber, so the whole chair can be fully recycled at the end of its life. And to close a loop with its customers, IKEA operates a buyback and resale programs in many markets, keeping products in use longer and preventing premature disposal. Our second case study answers the questions every operation leader asks. Does this actually pay? Schneider Electric took a facility in Lexington, Kentucky that was more than 60 years old, a genuine brownfield site, and transformed it into World Economic Forum for 4IR Advanced Lighthouse Factory back in 2020 and a Sustainability Lighthouse in 2021. The tools were digital: IoT connectivity, EcoStruxure energy monitoring, edge and analytics, predictive maintenance, and augmented reality. The results are on the slide. A 26% reduction in energy use through optimized energy management, 20% less equipment downtime, 20% less water use, plus a 90% of paperwork eliminated. The core insight, and it is worth saying slowly, sustainability and operational efficiency are complementary goals, not competing ones. An old factory did this, and other people's can too. None of this is happening in a vacuum. Regulation is actively reshaping the playing field, and there are three developments that we need to know. ESPR is the EU's eco-design for sustainability product regulation. Requires products sold in the EU to meet minimum and sustainability performance standards, covering durability, repairability, recyclability, and recycled content. The digital product passport attaches a digital record to each product with information on its materials, components, repairability, and end-of-life instructions, enabling circular supply chains and the informed consumer choices, as well as the EPR's policies that are spreading worldwide from the EU packaging and packaging waste regulation to state-level laws here in the US. Alongside regulations sit the certifications on the right. FSC for Sustainable Forestry, Green Seal, Cradle to Cradle, Fair Trade, and Blue Sign for textiles. Together, these frameworks create a level playing field and reward the companies that invest in circular design. So one final skill for a green practitioner is being able to tell genuine sustainability from greenwashing. Greenwashing occurs when companies make vague, misleading, or unsubstantiated environmental claims to appear more sustainable than they actually are. So watch the words on the side specifically. Eco-friendly, green, natural, sustainable. Without context, they mean absolutely nothing. Honest claims follow four rules. They use data-backed statements made with 80% recycled aluminum, recyclable after use, beats eco-friendly every single time. And they explain certifications clearly, what they cover, who verifies them, and just as importantly, what they do not cover. This gives customers clear instructions on exactly how to recycle, repair, or return the product. And you have to be transparent about limits. Acknowledge what has not yet been achieved and what the company is actively working to improve. Now, here's something to think about. How can individuals support circular economy efforts in their everyday lives? And what is one misconception people have about the circular economy that you think needs to change? So let's make all of this concrete with a 5-minute activity. Think of a common product from your work or daily life, a printer cartridge, beverage bottle, or a piece of coffee furniture. Identify where waste occurs in the product's life cycle, during manufacturing, packaging, use, or disposal. And think of one circular improvement that could be made. Could it be redesigned for repair, reused, refilled, remanufactured, or even recycled more effectively? After thinking about that, there are 3 takeaways that you can leave with. First, circular production starts with better design. Waste is designed out before a product is made, not managed after. Second, circularity is a system, not a single action. Producers, consumers, governments, and supply chains all play a role. And third, circular systems reduce waste while also creating economic value, lower material costs, and new revenue streams, and stronger supply chain resilience as well. Thank you. That'll be all for mine, and we can now transition to the expert Q&A discussion.
Okay, thank you so much, Rishab. I think you did an amazing job on your presentation, and I feel like we all learned a little more about circular economies and everything that comes with it. I had a couple questions for our experts, Dr. Ramesh Subramoniam and Mr. Ajay Vonkarey. Our first question is, what is the key difference between a linear and a circular economy to you?
Okay, you want me to go first? Ajay, okay. So, from a linear, and I think Rishab did a fantastic job laying out what a linear economy is, and what is linear production and what is circular production. So the clear process is you manufacture, you distribute, and you make sure that the products come back in the cycle. That's what actually helps with the circular economy. If you're linear, you're going to actually put it in the landfill, or you send it to the incineration plant, like what I saw a few months ago in Switzerland. So there's a lot of countries who are actually thinking about how much of their materials are getting incinerated, and you want to bring them back to normal life. It is becoming more of an important thing to consider, especially with the current challenges. When Rishab was actually walking through his presentation, I was thinking, what are the whys and the hows and the whats of his presentation? And the why is that we have a lot of disruption going on in supply chain, and lack of raw materials is in the top of the agenda for most of the government officials. And we look at all of that. What are we doing? We actually waste these materials, and then we run out of those materials, and then we have to seek out other materials from other countries. So that's a challenge for all the countries. And then you talked about how we can do it, keeping it at a higher value, which we will discuss as we move forward, in terms of recycling and what are the other ways we can do, recover those materials. And then the discussion on understanding the definitions, which I will definitely pay attention to, because there's a whole lot of confusion about recycling itself. Many people consider, they use recycling and refurbishment and reprocessing, and I've worked in different industries. Everybody was using different terms, and not understanding the definitions of these terms are also affecting the way we are managing the circular economy. So with that, I will pass it on to Ajay.
Thanks, Ramesh and Rishab. Great job. To kind of start out with, I'll say this, if you were to take a real life example, people plan trips, right? You go out, you want to go, I don't know, visit Europe, different cities, experience the food, the music, the culture and all. End of the day, you still want to come back home, right? That's circular. You go, you experience, you're out in the world, but you're coming back. So if you were to take that real life example into the manufacturing and the products, that's circularity, end of the day, right? The idea behind circularity is we want to ensure that whatever product has gone out, if not all, majority of it comes back to the producer, right? Instead of, what linear, which is you take it, you make it, and we don't know where the product ends. It could be a landfill, it could be a different country, it could be in the ocean. So there is no concept of getting it back. So that's a real life example I tend to give, what circular economy means.
And I think you did a good job. Sorry, of mentioning how like the resources, we're wasting a lot of resources and we have a finite amount of resources. So how do you think that apart from it being like environmentally harmful, how's a linear model more economically fragile as well?
Well, I would say that the key concept, I'm sorry, Ramesh, the key concept behind that is the cost of raw materials, right? So today we are bringing in raw materials right from scratch. So if you were to build a phone or a car, everything is new, everything is from scratch. So obviously there's a lot of cost behind it, not just the material cost, the supply chain cost, the production cost. But if you were to use 50% of the same product, the same materials which were used in the product, so that reduces your cost significantly, right? So that's a big difference is from a cost perspective, you are repurposing or reusing the same material where you don't have to spend a lot of time, effort, and energy, right? Because that's the key focus is energy is to ensure that now the cost is reduced, or rather cost is not even going up. That's the key that will help in regards to circular economy.
Okay, thank you so
Ramesh, you want to
much.
add anything?
Yeah.
No, I think you covered it. Thank you.
Okay.
Yeah.
I'll move on to another question, which we talk about the designment of products. When governments play a role in circulating and scaling circular economy practices, specifically, how does extended producer responsibility (EPR) incentivize how products are designed?
Okay, from
Yeah,
a
Ramesh.
EPR is spreading fast. I mean, there is across the EU. First step, when I visit EU, and I talk to my colleagues in Europe, there is a whole lot of discussion that happen, and products are getting designed, better. And I'll give you some examples of what I've seen in the auto industry where I worked before. We had an engine control module which we generally use for automotive vehicles, and we had an issue where the module was actually welded together. Okay, so when the design was created in the first place, nobody thought about the circular aspect of manufacturing it. So we came to aftermarket where we were actually trying to disassemble that product and we couldn't do it. So the only way we could then fix that was to change the design, right? So we were actually requesting the design engineers to reconsider providing them guidelines on what we do in the aftermarket so that they can actually, aftermarket is when the products come back and we had to do some work on that. So they finally changed the design. It took some years before they could really put together nuts and bolts and tighten it off, and then it worked out. So there was a great change in design. Then we could actually take volumes of these products coming back and remanufacture them, and so that we can put it back. And what did it do for the company? It actually helped with the warranty cost, because every product we were selling to the service parts organization, we were actually providing brand new parts, and brand new parts are expensive. So financially, these things make sense as well. So when we made that design change, we were actually now selling it for 30 to 40% cheaper to do the service warranty cost. So a significant reduction for that particular product line in the warranty space. Now, if you're asking about, so you specifically asked about the design aspect, so that's why I thought I would share that example. But the EPR rules and incentives, does that really impact, right? That's the other question you had. And the extended producer responsibility and legal regulations in general, you cannot say that it has a quick impact, okay? There has not been, when I look at the research work which has been done, there's not been real clear indication of whether EPR has resulted in more design, not a strong evidence to prove that. But if you take the design aspect and then combine it with other collaborative things companies do, potentially the whole process changes. Now you have more, because it's a collaborative venture that really makes these things work. So bringing even the old products back, that's an incentive mechanism you have to have. So if you don't have those kind of things, then the process is not going to work. So there are other things you have to consider as well. So I'll stop here and give it to Ajay for his thoughts.
Sure. Thanks so much. Again, great explanation of that. One thing I just want to add again, going back to lifetime example, right? If you were to go out of the house as a kid, it's the responsibility of the parents to make sure the kid comes back home, right? That's the extended responsibility. Now, how we take that in real world, to Ramesh's point, products are being designed in such a way now, or rather redesigned in such a way that there is an option for one to repurpose and reuse them, but also reduce the wastage around it. And I think Ramesh, you and I talked about that welding component, how they reduce the overall length of the weld, reduce it by 50%, right? So it's not just the reduction, you're reducing the energy usage, obviously the pollution behind the actual weld components. So that's an impact behind. Also, extended producer responsibility, the challenge with that is it's more of a regulatory requirement as of now. It's, just governments asking companies to include or redesign some of the products, right? What should follow after this is more of innovation, new ways of doing it, new design, new product designs, things like that. But yeah, that's I would say that's what EPR is basically
Thank you.
about.
I see that EPR plays a big role in how companies decide to manufacture or rethink of how they'll manufacture and create their designs. And when it comes to manufacturing, generally it's really good and so is recycling. But why do you think some companies prefer manufacturing over recycling?
Okay.
So Ramesh answered that. He's an expert.
Yeah. So remanufacturing is a very interesting topic because it has not been clearly understood. And I sit in the Remanufacturing Industries Council, and about 7 years ago, I should say, we were discussing this whole thing, like why is that the industries, this had a lot of different industry executives in this group. We asked the question, what is remanufacturing? Do you understand it? So, I think Rishab walked through that saying remanufacturing is product recycling because actually you're saving the value added to that product. So recycling itself you have to understand what recycling really means. It can be material recycling where you grind the product down to powder or raw materials and then use it for new products, or you have product recycling where you have actually saved the value you have added to the product. That's called value retention. So how do you retain the value? What is the value you're adding to the product? You're actually doing a casting on a part. You're machining the part. You're adding labor to it. So you're putting energy into it. Now energy is a big issue as well. We're discussing how we can save energy. So if in remanufacturing, what happens is it's product recycling. You're bringing the old product back. Like for example, if you have a cell phone, you're bringing the cell phone back and disassembling it, looking for any issues with it, and then fixing it and putting the product back together, right? That's remanufacturing, and then making it as good as new. So that is a different story than completely disassembling, throwing away some other parts, and raw materials gets used for brand new products when they start. So it's kind of going back to the foundation. So very different mentalities, and recycling actually takes away all that value addition. So you want to make sure. So the concept of remanufacturing it was not well understood by many people. So that's why it was not happening as much as it should be, even though financially it was a viable solution. So US is in the lead on that. They have about 50% of the total market in remanufacturing globally, and because of financial reasons. And Europe is very much into it because of environmental and financial reasons. And so, and again, keep in mind that we talk about remanufacturing and recycling. There are about 10 different R's, which you can use. They are like, refuse, reduce, reuse, repair, remanufacture, refurbish, repurpose, recycle, recover, remine, all of these things. We put together about 10 R's, and recently published a book on circular economy last year with my colleagues in Europe. So we had to actually dive into all of these different R's to understand, which ones are getting impacted during usage phase of the product, and which ones are getting impacted on the post-use. So that's the post-use is the time when the value gets destroyed. So you want to save as much as value as possible without destroying the product, like what we do with remanufacturing. Whereas recycling, I should say material recycling, takes it all the way to the very low end. So that's where the difference is. Ajay?
I see. And yeah, Mr. Ajay, would you like to add anything to that? Your own opinion on it?
No, I think Ramesh covered primarily the main aspect behind the difference between recycling and remanufacturing. In my opinion, I would say in current world where only, to Rishabh's point, only 7% of product is actually recycled, maybe that should not be even an option anymore. I think the next phase should be primarily more reuse, repurpose, or even reduce to some extent. Yeah.
I see the importance that remanufacturing, how it can have a bigger impact, a bigger positive impact than recycling, which is something that a lot of people do focus on. And it is important, but definitely to an extent. Do you think there's anything in specifically where recycling is the right choice?
Maybe in certain products where it cannot be remanufactured, it cannot be repurposed, right? That could be the next logical step. So for example, if you take a motor engine and the motor is burnt out, the shell, the case, the nuts and bolts can be reused, right? But then the cable behind it, right? The cable that's, that runs within the engine, that can be recycled, right? Because that's kind of worn out, but that can be used for a different purpose. But I would say again, from a economic perspective and also from an environmental perspective, redesigning and remanufacturing should be the focus than recycling.
Okay, thank you so much for your answers.
Yeah.
There's definitely a lot of misconceptions out there, and I feel like we're clearing some of them up. So for my next question, I had, what role does life cycle assessment play in finding where a product's environmental impact actually occurs?
Sure. I mean, basically what life cycle assessment, it's a process wherein now you're identifying right from end to end what your carbon impact and what your energy impact is. And what I mean by that is, right, for example, let's take manufacturing a car, right? Right from getting all the products, which is your metal, your leather, your rubber, right? Then going through the process from different manufacturers, right? From car manufacturing industry is a pretty complicated industry. And I know that's the example we are referring to. But as you go through that process, today, most of the focus is, okay, what's the quality of the product? What's the cost of the product? What's the impact, right? In the sense, how does it fit in the design? What needs to be added is what's the carbon impact of the product, right? In the sense, as you're using this product in the manufacturing, in the process, what are the carbon pockets? Where is that energy that is being used? For example, again, we go back to that welding, wherein there is energy usage because you're welding, a 12-inch long plates. Instead, if you reduce that to 6-inch, you're reducing the energy, you're reducing the carbon impact, right? That's the life cycle analysis. So where companies are right now is that kind of just scratching the surface of what this is, while they know that there is a benefit behind this. And benefit could be two ways. Again, there is obviously an environmental benefit where we can identify pockets or reduce those carbon pockets. But in turn, that will also be an economic benefit, right? Now you're using less scrap material, or you're repurposing an old product or an old nuts and bolt, bring it back into your manufacturing process. The second part of LCA is also the energy usage during the whole process. And again, I take the manufacturing of cars, you're putting, all the products together, all the individual components together, there's a lot of energy consumption. So through LCA, you can identify where that energy is being used. And then obviously by research, by innovation, how you can reduce that energy. Yeah, maybe in some cases, reduce the time to put those parts together. So that means you're reducing the energy behind it. And then, of course, from a manufacturing perspective, the whole manufacturing plant itself is a huge energy consumer, right? So how can you reduce the energy there? This also includes or extends to what we call as PCF, product carbon footprint, right? Life cycle analysis is more from a process perspective. PCF is more for a product perspective. So again, you take a product like an iPhone. Within that, you can break down right from the shell to the camera components to all the the chips in there. Then what is the carbon footprint for each of those? Right? We are not just looking at the cost and the quality and the safety, but also the carbon part of it. So large companies are slowly looking into that. And again, the idea behind that is two aspects. One, how can you reduce the carbon impact in addition to make it more economical? So that's basically what LCA is for.
And Doctor, would you like to add anything else?
No, I think you explained it very good. Thank you.
Mm-hmm. I think there's a lot that comes in with life cycle assessment and how you said how we get data, especially with energy use, which I think it's some of the more trickier stuff when trying to find the data. But what do you think are some barriers that limit or alter the data that it can be used for LCA? And how do companies keep it from moving up in the value hierarchy?
That's a great question, and I'm actually in the middle of it. Currently, I'm working for a auto manufacturing company, and they are in the process of doing their life cycle assessment. And I will say this, especially for folks looking for jobs, if you have LCA certification, companies are looking for it. So in addition to what you're doing, probably that could be a good add-on. But going back to answering question is data is key, right? Now, the challenge is this data resides at multiple sources within the same organization and also within their supply chain, right? With their vendors, with their transport companies, with their suppliers, different regions. Maybe, some of it is in Mexico, some of it is in Europe. So the challenge is consolidating all of that data. To that extent, there are processes defined from an academic perspective, but also there are tools, there are systems out there where it's more of a questionnaire. You go through that and then work with your teams, work with your suppliers, collect the data, consolidate all of that data into a central platform, and leverage that to do your assessment process, right? So there is a lot of pre-work that needs to be done as part of LCA. And the biggest challenge is the pre-work is not within the organization. It's also outside the organization. So that's when, a lot of other aspects come into picture, whether it is additional cost, just the regulations, maybe a company in Mexico might not be as ready to give out the data, right? Just based on the regulatory requirements. But data is key, and there are tools and mechanisms to build that data and go through the process. Yeah.
Do you think there's anything they should avoid doing? Anything in particular that you think stands out?
Just based on my current experience, I would say just don't jump the gun on LCA. Take your time to build your data platform because that becomes key. I'll tell you a very good example. After we did a LCA analysis on one of our very minute products, it came out that the energy that is being used is almost about 15 gigawatts, which is like, there's no way a small product could be using that much of energy, right? Because we missed out some of the data and the calculations behind it. So the key is take your time, gather data, make sure all the teams are involved, work with your vendors and suppliers. Then you're in a better position to do that assessment. So it's like building a house. Make sure that you have your foundation set up properly. Make sure you spend time building that foundation rather than focusing on, your rooms and your paintings and windows, things like that. So just a real life example.
Thank you so much. And we're moving on to our final question, and this one's about greenwashing, which Rishab also talked about in his presentation, and I feel is a very growing controversy around society. So consumers and regulators are getting sharper about greenwashing. What separates an environmental claim that survives scrutiny from one that doesn't?
Okay, I can give you some thoughts on that. I think the greenwashing has been going on for a while. I think many NGOs have protested and identified those problems, and the reputations of many of these companies have been impacted. One of them I can remember is the Fiji water plastic bottles when it came out years ago. From what I remember now is that that green leaf that was attached to it, it looked like the green leaf was actually a third-party certification on that bottle. And somebody who went after that said, this, I thought it was a certification, but it's not. They just put it as a green, way to do it or whatever. So you had to be careful. That's the point. I mean, when you do claim that, you have achieved something, in today's age, you have to make it clear to customers what you're trying to achieve. And I mean, there are many companies that have come out with blockchain solutions and other things. This is not a technology discussion, but the point there is to identify what the product has gone through when you get some products from, like when you buy something, and customers are going to have more visibility on these and transparency on these products. So make sure, whatever you're measuring, it's specific. And I think Rishab mentioned that you cannot be vague about it. For example, saying 60% recycled plastic, that's specifically pointing out what you achieved. Are measurable, like what we are discussing, and verifiable, saying we have LCA certification to support that, or LCA analysis done, or certifications from a third-party vendor. Identifying those things will be critical. Now, when you compare them, which ones are good ones and bad ones, many of the bad ones are vague, like saying, for example, eco-friendly packaging. When you say that, what does that mean? Or you say, I'm carbon neutral. Okay, now what? Like, explain what. So you have to give specifics. You can say reduced our carbon footprint by 22%, or we had verified LCA. If you provide additional documentation to support your statement, then people are going to trust you. Today we live in that world, and it's very easily such things can damage your reputation and put you in a very bad shape. So very important to watch out for that. So I'll leave it there and open it up for Ajay to talk.
That's a great point, Ramesh. The point I would like to make is just because a product looks green doesn't mean it's environmentally green, right? I mean, and the reason why I'm saying that is there are companies out there who tend to do that, whether it is just their labels or even the product itself, because that's an eye catcher for consumers, right? As you walk by in a grocery store and you think it is green because it's colored green. But I would say the data and the auditability behind that's what is important. Fiji bottle was a good example. A few years ago, Colgate toothpaste, the tube, they came out and say that, okay, the toothpaste, the tube is recyclable. That's great, but then they had a lot of limitations. You can't just throw it in your recycle bin, right? So the consumers are on the assumption that, oh yeah, okay, now it is a better product, but in reality, that's not the case. So a lot of education, a lot of research behind it always. And this is where the consumer stands out. This is where consumer has a responsibility, right? You need to do your research. You need to make sure that, what the claims are actually true. Only then you buy those products, right? There are companies out there, I'm sure you guys have heard of Shein, right? Fast manufacturing, fast fashion company, but their biggest downside is the amount of waste they produce, right? Yeah, you might be buying a product for cheap, but there's a downstream effect to it. So those are all greenwashing examples. The best way to address that is two. One is from a government regulatory perspective, reporting, auditing those reports, making sure there's enough data and examples behind it. And secondly, from a consumer perspective, consumers need to be aware as to, hey, what is this actually a true economically, environmentally viable product, or is it something that just making you buy by greenwashing it. So,
thank you so much. I think there's a lot that goes with greenwashing, and we have to be, us as people, everybody around has to be conscious and put in the effort to really look at it and make sure and see if it's actually certified, because we can't always base ourselves off the companies. But I think that's all the time we had today. Do you want to have any more last comments?
No, I think
Ramesh,
one last comment I would say about sustainability in general, and especially in circular aspects as well. Companies have to be realistic about it, because when you get into the business world, it's one thing to say we want to be environmentally friendly, but the company is also profit focused. So you have to have a good business case to support what you're trying to do. Otherwise, every company is actually involved in, as a person, you can actually decide I'm going to buy, some environmentally friendly product by spending more money. But in companies, they won't make that decision. They'll be looking at the business case. So, and that is one aspect of it, making sure that financially we can actually make it. And many of the things we discussed today, like remanufacturing and other things, are financially viable and also very attractive. And I think today's world, we can actually do all these things and invent more and more solutions, like both of you, two young people here trying to get into this aspects. You bring a lot of energy and new ideas to the table. And these are the ideas we need. And especially, I believe that when you build a constraint around anything, sustainability, I look at it as a constraint. And when you put that constraint around a linear programming problem, now you can find many solutions to that. And that's how you solve the problem. So, so be careful with that financial side of it. And also, I think Ajay pointed out earlier, we should not actually start in a huge way. Start small. Start with a small pilot, doing small things rather than doing huge things. And I've seen many companies fail to do such things. And you can actually do some simple things here and there and see how it works out, and how the organization takes it, how people react to it, how the consumers are reacting to it, rather than making a huge, massive change and finding yourself in deeper problems. So that is those are the two things I would like to share as a close out. And so thank you.
Great points, Ramesh. Just from my side, I would just say, at a very bigger scale, sustainability is more of a mindset. And what I mean by that is, when you go buy a product, you look at different aspects, right? You look at the cost, the brand, the quality, even the story of buying it. But in addition, as a consumer, you should also look at, is that product environmentally sustainable, right? That's key. That's from a consumer perspective. And to Ramesh's point, from a corporate or company's perspective, the mindset shift is now sustainability is not a cost center anymore. It's not something where it's an additional cost to the business. It's actually a potential revenue to the business. So that's how they should be looking at, because as the consumer mindset shifts, the product requirements and the corporate requirements shift. So that's my 2 cents. Again, sustainability is more of a mindset shift. And, of course, it's the younger generation who's leading it. And, hopefully the world will be a better place in a few more years, a few more decades, hopefully.
Thank you so much. I really, thank you, Dr. Ramesh Subramoniam and Mr. Ajay Vonkarey. We learned a lot, and it was wonderful having you guys here. This was exactly the bridge from theory to practice that we needed. And if anybody has any questions for our experts, feel free to reach out to us through the email learn@oneearthonechance.org, and we will provide answers for you from our experts. Thank you, Rishab, Sunil as well, for your presentation. It was wonderful. And the founder of this whole nonprofit, and our first Green Practitioner webinar, Kira Menon. Thank you.
Thank you all.
Thank you.
Stay green.